Okay. So we're going to set this up like this. So here's our step 3. We're going to have a statement and a reason. All right? Every statement that you make in step 3 needs to have a reason to back it up. Okay? So this is the same stuff that we've been doing. It's the same stuff we've been doing. Just now I'm going to kind of break it up. Your reasoning should all come from your notebook with these definitions and axioms. Okay? So does anybody remember how our explanation for this went?
You drew a circle centered B.
Okay, I'm sorry. I want to back up a second. We want to say that ray BD, right, divides angle ABC into 2 congruent angles. Okay? So somewhere we want the statement angle ABD, this one, this angle, is congruent to what?
BDC.
Angle, not BDC.
BC.
No. You have to say B in the middle. So you can say CBD or you can say DBC. But this angle, you knew what you were talking about.
Why do you have to say B in the middle?
Because you have to follow the order of the angle. So if you say BDC, that would be like this angle. Yeah. So that'll be important, especially when we start talking about triangles. You can't just throw any 3 letters because that's the 3. It could be any 3 angles, any of the 3 angles. So at some point we want to say this. We want to say that these 2 angles are congruent to each other. And then if we say that, then we can say that ray BD bisects angle ABC. And then the reason that we can say this is by definition of, nope, bisector. By definition of bisector, right? Isn't that what the definition of bisector is? Ray BD bisects ABC if the line before it, angle ABD, is congruent to angle CBD. If it cuts it into 2 congruent angles. If I can say that these 2 are congruent, then I can say it's a bisector by definition of bisector. Okay? So we want to get to the point where we can say that these 2 angles are congruent. But we're not there yet. What are some things that we do know? What are some things we do know?
Is it BD and BD congruent?
BD is congruent to BD.
By reflexive property.
Okay, so I can say that. I can say BD is congruent to BD, and my reason is
By the reflexive property.
the reflexive property. Okay, we can say that. Reflexive property should be in your notebook, so it can be a reason. All right? Remember, reflexive property means that anything is congruent to itself. So I can make this statement, but then I have to have my reason. All right, what's something else that you know is true or know is congruent?
ABD is congruent to CBD.
That's what we want
Oh,
to
never mind.
get to say eventually, but we don't know it yet.
A is congruent. No, never mind.
A is just a point.
AB is congruent to CB.
AB, this section right here, is congruent to CB. Is that true?
Yes.
Why? Why is it true?
By definition of radius.
Uh-huh. These are both radii of the same circle, so they are congruent to each other. All right, what else can you say? We've said that BD is congruent to itself. We've said that AB is congruent to BC. What else can we say?
Okay,
Where's the line that
AD.
you drew last time?
What did you say?
AD
AD.
is congruent to CD.
AD and CD. Are they congruent?
Yes.
Why?
By definition of, is that by definition of radius?
Is it?
Yeah, it is.
Why?
I don't know why, but I know it is.
Well, how do I know?
Because the midpoint, the point, it intersects on both circles.
Okay. Circle A has a specific radius. Circle C has the exact same radius, right? AD is a radius of circle A. CD is a radius of circle C. Since the circles have the same radii, then these two segments are congruent. So that's by definition of radius as well. All right? So now I've said that this side is congruent to this side. I've said that this side is congruent to itself. And then now we just said that this side is congruent to this side. So what does that mean?
That they're all congruent.
What's
That
all congruent?
ABD is congruent to, angle ABD is congruent to angle CBD.
Okay, we can't talk about the angles yet.
Side.
Can't talk about the angles yet.
Side.
We've talked about three sides. What has three sides?
Triangle.
A triangle. So what can we say about these triangles?
Where's the line that you drew across?
I never drew that line. Y'all did. What can we say about these two triangles?
That they are. What he said.
Supplement- No, they're not supplementary.
They're not supplementary.
Triangle. Oh, by side. Axiom 2.
What about side, 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 axiom 2?
Side. Dang it.
Triangle.
Oh, triangle. What is it? ADC.
No, that's not one of the triangles that we've talked about.
Oh, it's this way.
Yes. This is a triangle.
ABD. Triangle ABD
And
is
this is a
congruent to
triangle.
CBD.
Triangle ABD is congruent to triangle CBD. Is that true?
Yes.
A and C have to be corresponding. B and B have to be corresponding. D and D have to be corresponding. All right? Now we can say side, side, side because we've listed the first side, the second side, and the third side. But we can't say side, side, side until we list all three sides. That's axiom 2. And you should have that in your notebook. And we're getting to the point where you're going to be using your notebooks on your quizzes. So that's why you want to make sure you keep it up to date. All right. Now can we say that these two angles are congruent?
Yes.
Why?
By axiom 3.
No.
I don't know this. Dang it.
We just
Okay.
said that these two triangles are congruent.
Okay, so the angle.
Are the angles part of the triangles?
Yes.
Are they corresponding parts of the triangles?
Yes. Is that the
So what is CPCFC?
corresponding
Corresponding parts
of
Congruent figures are not corresponding, congruent. Corresponding parts of congruent figures are congruent. So now we can say that this angle is congruent to the second angle that we created by this bisector. If these two angles are congruent, that means that BD bisects ABC by definition of bisector, which is what we wanted. We wanted to construct a bisector. So if we get to the point where we can say that these two angles are congruent, then that means that we have a bisector. It is. All of this side is written down in your notebook.
Should be.
Should be, yes.
Just bring that up. You need it.
Put it down in your